This conference will now be recorded.
Okay, so this is Big Data Master's Program, and today, we will focus why we need to jump in this particular big data domain. Okay, so our main focus is onto the why, like why we need to learn this Big Data Masters Program, why we need to take, what are the benefits that we can have with the help of this particular program. Before moving further, I just want to give you an insight, like from where this particular word big data came. Okay, like we know what is data. Okay, then what is big data and why we need to learn these particular things, we need to focus in today's session. And more or less this will be the introductory session, where we are going to find out certain aspect, like what is big data, what are the different things in order to process big data, what will be the future if we are learning big data. So such type of things we are going to learn in our today's session. So big data, let me pick up this particular word and mention over here. So if you are able to see, friends, big data is the combination of two words, big and data. Data, we know, like the collection of facts and figure, collection of facts and figures. So once we are having certain amount of, you can say, information, or like once we process that particular data, we can say, like in a room there are certain students, or some students are there in room. So that is nothing but data. Okay, example, I can say some students in the room. Okay, so that is nothing but a data. Like we are having certain data over here in terms of some students, huh? But once we process this particular data, then it will give us information. What it will be? Processed data. Say 26 students are there in room, huh? 26 students are there in room. So what we are able to identify over here, certain informations, because like we have processed the data and we are having some numbers. Okay, now focus on to the big data. So friends, like we are having data, but once the data is there in huge quantity, yeah, big data, once the data is there in huge quantity, like volume is high, and that is generated at very high speed, velocity, and that is of different type, variety, yeah. So volume, that is denoting the size, velocity, that is denoting the speed, variety, that is denoting the type of data. It might be, say, structured or unstructured data. Same structure is also there, and same structured data. Okay, so volume, velocity, and variety, these are the three characteristics by which we can say the data is big. Like we are having big, huge amount of data that is generated with high speed and having different types of data. Structure, like in terms of tables, unstructured in terms of, say, image and videos. Okay, now big data, like, is this the only, you can say, aspect by which we can say the data is big? So big data is denoting the processing capability of a particular machine. Let me take an example. Say I'm having uh, say P5 machine that is having 16 GB RAM and say 512 GB of storage. 16 GB of RAM, 512 GB of storage. So this particular machine is there, and I'm say going to process say 200 MB of data. 200 MB of data need to be processed. So definitely with this particular machine, which is having this particular configuration, I will be able to process. But if I'm having 2 TB of data, then will I be able to process with the help of this particular machine? Definitely not.
No, sir.
I will not
No.
be able to process. Guys, please go on mute. Once like I will ask, then you can have the Q&A session. So 2 TB of the data is there and the P5 machine will not be able to process. So for this particular machine, friends, this is big data. Okay, we can take another example. Say I'm having P1 machine and which is having say 1 GB RAM, or we can say 512 GB of RAM, or we can say 120 of or you can say we are having a machine say 486. The initial computers that we were having, so say that was having say 120 GB of RAM and say uh, say 1 GB of the 1 GB of say storage, hard disk, what you can say. So for this particular machine, or let me take say the smaller size, okay, 1 GB that is fine now. So for this particular machine, say I'm going to process a 1 GB of the data, or say 2 GB of the data, 2 GB of data I want to process with this particular machine. But this particular data is exceeding the configuration of this particular machine. This particular machine will not be able to process this data. Okay, so that is the limitation of machine. Once a particular machine is not able to handle a particular data for that particular machine, that will be big data. Okay, it is depending upon the processing capability of a machine. If the machine is not able to handle, so that will be big data. Forget about the velocity and variety. Okay, or take it in this way. Say I'm having a machine of say 64 GB of RAM, 16 GB of RAM, and probably like this 1 GB of data I will be able to process over here with the help of say P5 machine. P5 machine was able to process this 1 GB of the data, but once I'm having the 486 machine, this machine is not able to process this particular data. So for this particular machine, this is big data, and for this particular machine, this is the ordinary data. Now, what will be the mechanism with the help of what I will be able to process this data? Okay, so there are certain aspects. In 2003, Google has observed that data is increasing with very high speed, and our current machines will not be able to handle that data. Okay, so they have published certain white papers. Google. in 2003, let me mention in this way, Google published white papers, and what those white papers were saying, like how to process huge amount of the data. Once a particular machine is not able to handle that particular data, then how we will be able to process. So those white papers were taking having the solution. That was not implemented solution, friends. White papers are having the methodology, how to deal with a problem. Okay, so that is the methodology. White papers are having the methodology only, that is not the deployed solution. Okay, based upon the white papers, if like the mechanism is working, we can have solution. So in 2003, what Google has published, that was not the solution. Okay, but how, that was not the deployed solution, you can say, available in the market, but that is a mechanism. That was a mechanism with the help of that we will be able to handle the huge amount of data. So once we talk about data, there are two main aspects, storage and processing. Okay, if like a particular machine which is having the capacity of 1 GB and I'm giving 2 GB of the data, definitely it will not be able to store. Okay, and if 1 GB of the data is there, at that moment as well, this particular machine will not be able to store, because like operating system will occupy certain space onto the disk. Okay, so 1 GB will not be available, entire 1 GB will not be available. And if you check your storage or hard disk, and if it is saying that you are having 512 GB of the hard disk, so complete like storage will not be available, huh? So storage is an issue. At that storage was the issue, like we were not able to store the increased amount of data. So first is like we need to store, if the data is huge, we can be able to store that particular data. Second, like if we are having certain amount of data in our storage, that is not making any sense until unless that is not processed. Means until unless we are not having information, that particular data is not making any sense. Okay, so we need to process that particular data. So storage and processing, these are the two aspects which are attached to that particular data, and Google has provided the solution in order to tackle with these particular problems, how to store huge amount of data and how to process huge amount of the data. So with respect to the processing or storage, they have published paper, that is distributed storage, that was distributed storage, and they have given a name, GFS, Google File System. Google File System was the name what they have given. So distributed storage, what it was exactly? So distributed storage was like, instead of deploying one machine to handle 1 GB of the data, say if I'm having two machines, then definitely I will be able to handle this particular data. Okay, or three machine or four machines, so combination of machines will be taken care. Okay, instead of one machine, one monolithic machine. Guys, try to focus on to the words basically. Say monolithic machine, monolithic machines means single machine or single computer, one computer, whatever. So monolithic machines was not able to handle huge amount of the data. The concept came in order to resolve the storage issue, that is the distributed storage, and Google has given a name, that is Google File System. This is the similar, you can say, stuff that we are having inside the Windows, say NTFS that is nothing but new technology file system. FAT32, okay, file allocation tables, like how to manage the storage if we are having multiple machines and we are having certain amount of data, then how to place that particular data inside the storage. So distributed storage was the concept that was given by Google in 2003 with respect to the white papers. Then, until unless we are not processing that particular data, that is not making any sense. So in 2004 they have published another white paper, that is distributed processing, and they have given it a name, MapReduce. Okay, MapReduce. So MapReduce, this is the combination of two words, mapper and reducer. Mapper and reducer. So you can take it in this way. Uh, say I'm having 10 sticks, and I am going to like I'm giving it to one person, and I have given a command like to break all of these 10 sticks, and say if uh, one person take takes 1 minute to break one stick, then 10 minutes in 10 minutes he will break all 10 sticks. Okay, okay, so 10 sticks were there, one person was aligned to break all those 10 sticks. So if one stick is broken is in 1 minute, then in 10 minutes he will be able to break all 10 sticks. So that is the monolithic processing, like I'm giving certain task to a particular machine, and that is the only machine which is able to, you can say, handle that particular data. Now if I aligned, say, 10 persons and to broke these 10 sticks, then in 1 minute all 10 sticks will be broken up. Okay. So same concept is applied over here, distributed processing. Like instead of utilizing one machine, then multiple machines was used in order to process certain amount of data, and this is nothing but the distributed processing. Okay, and they have given a name called MapReduce. Okay, so these were the concept only. Okay, at that moment these were the concept only. In order to handle huge amount of data, like distributed storage can be done, distributed processing can be done, and we will be able to solve our problem. But these were the concept only. uh, Duck cutting was a person who was observing these particular papers, who was reading these particular white papers, and based upon these particular white papers, he has developed a solution, Hadoop. Okay, Hadoop. So Hadoop is working onto the same concept, that is distributed storage and distributed processing. Okay, and inside the Hadoop he has changed certain, you can say, methodology. He has given a name, HDFS, to the storage part, Hadoop distributed file system, and MapReduce was kept the same. MapReduce. Okay, MapReduce. Uh, in order to understand MapReduce, let me take an example. Say you are having four machine, and you want to have the calculation of 1 to 100 numbers. You want to find out, say, sum of 1 to 100 number, 1 to 100, you want to find out sum, okay. Four machines were there. So inside the mapper phase, mapper, what will be done? This particular, you can say 25, say 1 to 25, 1 to 25 will be given to, say, machine 1, okay. 25 one. Then 25 to, say, 50, 20, 50, 26 to 50 will be given to machine 2. Then 51 to 75 will be given to machine 3, machine 3, and 76 to 100. Now this will be given to machine 4. So machine 4, what these machine will do, like it will provide the sum, say 1 to 25, okay, say sum 1, and it will be giving the sum of, you can say 26 to 25, sum 2, and in the same fashion you will have sum 3 and sum 4 as well, okay. So guys, these are the intermediary output, 1 to 25. This is the mapper phase. You have distributed all of the data among different four machines, and they have given intermediate result, intermediate results. So once you are having intermediate results, then what you need to do, you need to have some 1 plus some 2 plus some 3 plus some 4, okay. And that is nothing but reducer phase, okay. Reducer, reducer phase. So reducer phase will give you the final output, okay. So that is nothing but overview of map and map reduce, how the functioning is happening, mapping is dividing the task among different machine, reducing, converting the intermediate outcome to the final outcome. That is the reducer phase. Guys, just have a look onto the stuff that I have discussed so far and ask if you are having any doubt. These are the basics only, but still if someone is having any doubt, or is not able to digest the content, he can ask. Anyone having any doubt, any query? Friends, please be interactive. If you are able to digest, then that is fine. If you are not able to
That's
digest,
that's okay, sir. Fine.
okay, perfect, so Hadoop was utilized in order to handle huge amount of the data with the help of SDFS and MapReduce. So that was the concept. Now there are different components inside the Hadoop ecosystem. We will be having a overview on those particular, you can say, components. But before moving further, uh, let me try to give you certain insight. Say, cutting. Okay, so mapper, MapReduce, and SDFS was the concept inside the Hadoop ecosystem. But like inside the distributed processing, we are using multiple machines. Once we are having distributed processing, and say if we are not having Hadoop and we are going through with the distributed processing only, then what is the difference between both of these two aspects, huh? So distributed processing, or you can say Hadoop, both are having, you can say, utilizing multiple machines. But inside the Hadoop ecosystem, that is the master slave architecture. Hadoop is master slave architecture. Master slave architecture, huh? So master, inside the master and slave, what is happening? Say if we are having one master and different slave machines, slave 1, slave 2, slave 3, slave 4, huh? Say we are having a 5 node cluster, and in 5 node cluster we are having one master and remaining 4 are the slave machines. So this particular master machine is having the information like what is going on among these particular slave machines. In the Hadoop terminology, we call these machine data node, data nodes. The data node 1, data node 2, data node 3. Okay, but and this master is having the control. Say if this particular machine is failed, then how to distribute the load among available machines. So each and every machine is giving heartbeat message to the master machine and saying that I'm inside the system only and I'm working on to the task that you have given to me. So master and slave architecture is having this particular beauty. But inside the normal distributed processing, where like we have connected multiple machines and we will be able to process and store the data, but at that moment, like this particular, you can say, monitoring mechanism is not there. So Hadoop has removed or minimized that particular issue, and inside the master and slave architecture we are having this particular, you can say, beautification, and we are able to handle, if a machine is down, then we are able to handle. If we need to add more machines, then that is also possible. Okay, if we lost the data, then it can be recovered from the remaining machines, because we are having the concept of replication over here. What I'm talking about, like the benefits of Hadoop with respect to the distributed processing or distributed systems, basically, yeah. The systems which are processing and storing the data in distributed manner, we can say distributed systems. And Hadoop is also like a sub part of distributed systems, because like it is having multiple systems and processing is being done with the help of those particular, you can say, machines which are available inside the cluster. But it is having better control with respect to the previous stuff. Now that is fine, huh? Like we have gone through with the concept, say what is data, what is big data, then how to handle this particular data. Okay, so we are having the concept of Hadoop and all. But there are certain limitations inside the Hadoop, huh? Limitations. What are the limitations? Say Hadoop is disk processing system. Hadoop is disk processing system. Disk processing system, what does it mean? So it means, uh, say if we are having certain chaining process, slave machine 1 is working onto certain data, then it is giving the result to the slave 2, then it is, you can say, giving the result to the slave 3. Okay, and then finally it is giving the result to the slave 4. With what it will be processing onto the data, and you will be able to find out the information, the final result. You will be having the final result. But once you are having, slave machine is nothing but the combination of three things, or any machine in this particular world is having three main things, like processor, processing capability, you can say core, basically like processing cores. Then you are having RAM, and you are having storage. These are the three things which a particular machine is having. So over here, once a particular slave machine is working, and after like processing the data, what it will do, it will store it inside the storage, and from storage it will be moved to the slave machine 2. From once we need to do the processing, then from the storage the data will be moved. So let me open an Excel for the better clarity. Okay, say you are having processing core, RAM, and storage. These are the three things what we are having, no? So once a data is there inside the machine one, so machine one, what it will do, it will process this particular data, okay, and store the result inside the storage. From storage, it will be moved to machine 2, and from inside the machine 2 it will come inside the storage of machine 2. Then this particular machine need to work onto the data which is given by machine 1. We are talking about the chaining process. Okay, however, like the normal processing, these particular machines are working onto the different data, but in order to give you the understanding about like how the latency is high inside the Hadoop ecosystem. So I have taken this particular example. So machine 2 will take the data, it will keep it inside the storage, then it will be moved inside the RAM for processing, because like processing is done uh, inside the RAM. So then the processing is done, and after processing the data will be moved onto the disk again, and then from disk it will be transferred onto the machine 3. Okay, machine 3. Machine 3, what it will do, it will come it inside the storage of machine 3. From storage, it will be moved to RAM, and processing will be done. And then result will be stored inside the storage. So from storage, it will be given to the machine 4. It will be given, it will be, you can say, given inside the storage of machine 4, then it will be moved from storage to memory or RAM. Okay, so and over there processing will happen, and you will be able to get the final result. So over here, like input and output is more. Okay, input and output means like IO operations, say transferring the data from, you can say, one system to another system. IO operations, like data movement is there from one machine to another machine, and this particular concept is called shuffling. Shuffling. Once a data is moved from one machine to another machine, that is called shuffling, and inside the big data world, this is the very costly operation. Okay, we will be learning different optimization techniques, how to minimize this shuffling. And if you are able to minimize shuffling, then you can say you have done good optimization. So movement of the records, movement of the data is there from one machine to another machine and from RAM to storage. Okay, RAM to storage. So because of this, the latency inside the Hadoop ecosystem is a little bit high. And because of the latency issue, okay, because of the latency issue inside the Hadoop ecosystem, then another you can say concept came, that is Spark. Okay, Spark. We can say like in order to minimize latency, which was observed in Hadoop ecosystem while processing with MapReduce. While processing with MapReduce. So Spark came into the picture and it is in memory, lightning fast compute engine. So Spark has minimized the issue which was there inside the Hadoop ecosystem, and that was because of the IO operations. IO operations was taking too much time, and this is lightning fast compute engine. Over here, say HDFS was there inside the Hadoop ecosystem plus MapReduce. So these are the two things. HDFS Hadoop distributed file system that was used for storage. MapReduce, that is the processing framework inside the Hadoop ecosystem. And another you can say component is there, that is RM, resource manager. Resource manager. So this is the combination of you can say like we can say these three components are the main part of Hadoop ecosystem: HDFS, MapReduce, and resource manager. Resource manager is managing all the resources inside the cluster. MapReduce is going to process the data which is there inside the HDFS, and HDFS is there utilized to process the data, to store the data. Okay, so there was what I said, like certain limitation with respect to the latency was high once you were using MapReduce. We will be learning these particular things in detail, but today I'm going to you can provide the overview what is being happening, why we need to learn different you can say technology. So Spark is utilized in order to minimize the latency. But can we say like Spark will replace the Hadoop? No, Spark is working in this particular way. Over here, like the compute engine which was there inside the Hadoop ecosystem is replaced by Spark. Now we are able to do the processing inside the memory, and it is providing the results 100 times faster once data processed, data processing done in memory, and 10 times faster once data processed on disk. Data processing done and done on disk. So because of this particular reason, like Spark is penetrating inside the market. Like there is heavy demand of Spark engineers, the persons who is having Spark knowledge, that is having uh, high in demand, who is having high in demand. So Spark is the mandatory skill nowadays in order to jump inside the big data domain. So Hadoop was having certain issues, and Spark has minimized those particular issues, and how it has utilized by replacing the compute engine from the Hadoop ecosystem with the help of Spark. Now you will be able to process the data with low latency, and you will be able to get the result faster compared to the Hadoop ecosystem. Okay, so Spark is having these particular benefits. Now, just have a look, guys, onto this particular thing and ask if you are having any doubt. Then we will move further.
Sir, wait a minute. Just I want to one question. In
Mm-hmm.
Hadoop system, this is please please done something above the page.
Mm-hmm.
Yes, yes, sir. In Hadoop system, the map reduce is a compute agent. Okay, sir. But in
Mm-hmm.
Spark, it's replaced by Spark. Is Spark is a compute engine or something else?
Spark is compute engine only.
Okay, means it's faster than MapReduce process.
Hmm. Right.
How it's
Spark,
faster? How it's fast?
because it is processing. Over here, the processing is done inside the memory. The disk is not, that's what I have explained. Over here,
Hmm.
if this particular machine is processing, then after processing, it will move the data onto the storage. From storage, the data will be moved onto the storage of that machine too, and from storage, it will be moved to RAM for processing. Once the processing is done inside the storage RAM, then it will be moved to storage. But how the functioning is done inside the Spark, it is, you can say, RAM. Okay, once the data is coming, okay, say data you are having input, it will be processed with machine 1, okay, and kept inside the memory. Then machine 2 will work onto the memory only, and the output will be inside the memory. Then machine 3 will be working in on that particular data, and the data will kept inside the memory only. Okay, then it will be given to machine 4, and it will be processing onto that particular data which is inside the memory, and you will be able to get the final data. So movement of the record from RAM to storage has not happened over here inside the Hadoop ecosystem. Sorry, inside the Spark
Spark. Okay,
ecosystem.
okay, okay, okay,
Okay, so
okay,
that's why like it is having low latency compared to the Hadoop ecosystem. Like over here, the shuffling is not. We are having less shuffling over here, and the movement of record from RAM to storage and storage to RAM is not there, right?
okay, okay, okay. Yes, thank you.
Okay. So because of this particular reason, it is Spark is fast, and for a data engineer, Spark is the mandatory skill. We will focus in detail onto the Spark. We will be learning Spark, uh, multiple there are multiple components inside the Spark, say RDD, data frame, data set, okay, batch processing, streaming processing. So we will be going through with all of those particular topics in our course module. So Spark has, you can say, reduced the latency, but you might be worried, like I have discussed about big data, I have discussed about the distributed processing, then Hadoop came into the picture, then Spark came into the picture. But why we need to learn, like data is increasing, that is fine, but what is the betterment that this particular data is giving, what are the different applications of this particular data or big data? So let me walk you with the presentation so that you are having better clarity. So this is the big data masters program, friends. And this was the agenda, like big data, data exploding applications, huh? So big data refers to large volumes of structured unstructured data, and that will be analyzed and processed to get the insight, huh? Now data is exploding. This is the, you can say, uh, snapshot what has happened in 2020. Okay, in a minute, and say this is the this much of the video. 500 hours of video was uploaded by the users onto the YouTube. This much of the storage was on Instagram. These were the users, connected users onto the teams. Okay, this was the message in a minute onto the WhatsApp. Okay, these are the Twitter, you can say, users in a minute for 2020. So this is the, you can say, data which was generated in a minute onto these particular data sources, and once we, you can say, calculate this particular data, so it is expected, it is projected that the data will be, you can say, 160 zettabyte by 2025. Okay, if you are having this much of the data, and at this point of time you are able to analyze only around 10 to 15% of the data, and rest data is not being analyzed. Okay, if this much of data is there, at this point of time we are having around 60 zettabyte of the data. Okay, and what if we are having 60 zettabyte of the data, and by, you can say, 2025 it will be 160 zettabyte, then the resource who are working in this particular data domain, the demand will be high. That's why, like, we need to focus on to this big data world. The data will be generated, the demand for the persons who are going to handle this data, the demand will be high. And if the demand will be high, then the package and all, that will be, you can say, good with respect to the market, like other domains which are available inside the market. So in the big data world, in the big data domain, the package and all that will be good. So that's why, like, we need to focus on to the big data domain. Second thing, like the application. So package and all that is fine, but what are the different applications? So big data is there almost in each and every domain. We are having banking sector where, like, big data applications are there, communication and media, healthcare, manufacturing, transportation, education, retail and wholesale, insurance. Almost in each and every sector, we are having the applications of big data. So if, like, you are working in a domain, say you are inside the finance sector, and say you have done BCom or MCom, or you are CA. So you are CA, then definitely, like, you will be having the knowledge about the finance domain. But if you, with the help of that finance domain, you are having the knowledge of big data and its component, then definitely you will be able to, you can say, gain the command, and you will be able to analyze the data with respect to different, you can, different domains. Say finance is there in each every domain. Say subdomain, basically, you can say telecom is having finance. Say uh, stock market exchange is also having its own finance, healthcare is having finance, so you will be able to take the benefit, and you will be able to deal. You can take it in this way: person who is having, say, mechanical knowledge, and but nowadays what is happening, say IoT devices are there where the mechanical engineer is in demand, because the combination of IoT, the combination of mechanical and AI, that will form IoT devices. So over there, like, the mechanical engineer will take the benefit, and that is possible, like, if he is having the knowledge of this big data and AI. Okay, if like the person is there inside the telecom domain, okay, so um, he will be able to shift to the different domain because big data is there onto each and every domain. Big data is there, and what we need to do, we need to capture, we need to get the insight, and we will be able to, you can say, roam around the different domains. Let me take it in this way. Say, big data application, application. What I planning to say someone of you is from the telecom background. Telecom background. Okay, so telecom is having big data. Okay, then say finance background. So over there you are having say big data. Okay, and say stock market exchange, healthcare domain, healthcare background. Over there you are having big data. Okay, so if you are able to, if a person is able to gain the knowledge of big data and its technology, big data is there everywhere, then a telecom person can be able to roam or can be able to work inside the finance sector, and he or she will be able to work inside the stock market exchange as well, or inside the healthcare. We are having different, you can say, domains, say gaming, banking, different domains. But big data is there everywhere. And if you are having the knowledge about these particular components, like different components about big data, okay, processing and storage framework, so you will be able to roam into the different domains. You will be able to deliver into the different domains. You will not be stick to the single domain. You will be able to get the opportunity from the different domains, and that's why, like, if your penetration is gaining, then your demand will be more. The person who is limited to telecom knowledge, he uh, he's not having say the big data components knowledge, so he will be able to search the jobs inside the telecom domain only. But by gaining the big data components knowledge, he will be able to roam into the different, you can say, domain, and at that moment the demand will be high, and if demand will be high, then you will get the desired compensation or package basically. Yeah. Compensation is with respect to a particular issue in order to compensate you. But you will have the desired package. You can bargain to the recruiters that you want this much hike with respect to your current package. So big data applications are there into the different domains. I have taken the example of certain domains, like what are the different examples. A retail domain is having say, supply chain management, market and customer segmentation. In telecom domain, we are having revenue assurance and price optimization. These are the use cases which are currently going on into the different domains. So customer churn prevention, call detail records inside the e-commerce and customer services. You are having event analytics, right offer at the right time. Okay. uh, then market basket analysis. Okay. And recommendation engine, let me explain something about the recommendation engine, which is, say if you are going to purchase something onto the Amazon, then if you purchased a particular product, then it is recommending that those who has purchased this also purchase this, huh? So that is nothing but the recommendation engine, huh? And with the help of that, Amazon is able to gain huge sale at this particular moment, huh? Around they what they are commenting, around 28% of the sales are because of the recommendation engine, huh? Initially the accuracy was not good, but nowadays as the data they have captured more and more, so that the accuracy is more at this point of time, and they are able to gain sale by 28%, and that is because of the recommendation engine, huh? So a lot of, you can say, active use cases are there in each and every domain based upon the big data, and that's why like we need to jump inside the big data world now. So that is the thing. We have gone through with these particular aspects, say distributed processing, then challenges in the distributed processing, load balancing, bandwidth, scalability, fault tolerance. Load balancing, like uh, load was not properly distributed. Okay, limited bandwidth. Say if five machines are there, uh, load balancing, what does it indicate? If five machines are there, then one machine is working, might be four machines were sitting on idle, huh? So that is load balancing, huh? Limited bandwidth, say if we are having four machines, we will not be able to add fifth machine. That is complicated process. Same thing is scalability, like we will not be able to scale up, huh? Then fault tolerance, if a machine is down, then you will not be able to get the information that a particular machine is down and who is going to handle that particular machine load, huh? So in order to resolve the issue which was there inside the Hadoop, inside the distributed processing, the Hadoop came, and Hadoop has these particular components, huh? So just focus on to these particular components inside the Hadoop ecosystem. Like we are having in certain components for the ingestion, like scoop is there, flume is there. Scoop is there for the structured data, flume is there for unstructured data. So ingestion will be done with the help of this particular tool, these particular tools. Now Hadoop core, over here we are having this like storage, and then the resource manager, the third component which I already told, and MapReduce for processing, and we can replace MapReduce with Spark. Okay, and we will be able to process the data which is ingested with the help of these tools and kept onto the disk. Okay, so data processing is done. We are having certain tools for data analysis. Pig, Hive, and Impala, these are the tools which are used for the data analysis. Then, in order to explore the data, like it will provide the GUI, Cloudera Search and View. This will provide the GUI view for the data exploration. Uji, that is the workflow system basically, and it is similar to, say if you want a report at 9 a.m. on daily basis, then you can schedule the job with the help of Uji, and you will be able to get the report at 9 a.m. on daily basis. So scheduler, you can say for scheduling perspective, you are having Uzi. NoSQL database is there, so it is utilized in order to query data which is stored inside the HDFS. So HBase is nothing but NoSQL database. At this point of time, just try to think like we are having certain tools for ingestion, certain tools for processing. Okay, and then in order to have reports and all, in order to query onto the data and all, and in order to explore through GUI, So we are having certain tools. No need to go in detail, but just have a look uh, from the top. So different tools are there inside the Hadoop ecosystem in order to do a particular task. Okay. Then moving further, okay, let me discuss about this. So applications were there, different applications inside the different domains. And if you are having the knowledge about big data world, big data components, then you will be able to move into the different domains. You will be able to get the jobs into the different domains, huh? Like some of my friends like who has gone through with our course module. So earlier they were working into the telecom, now they are working into the healthcare domain. Some of them are working into the uh, finance domain, banking sector. Some of them are working into the telecom domain itself, but onto the different role, huh? So that is because of the big data only. Yeah. Now, moving further, component of not the component of like journey. Yeah. Say data ingestion, then data processing, data ingestion, data storage, data processing, and reports, charts, or UI view, dashboard. You can say. So in the big data world, guys, these are the basic operations. This will be the end-to-end data pipeline, huh? Like you are having certain data which is placed onto the or a particular location. Then what you need to do, you need to ingest the data. You need to you can say you are having data on a particular machine, and you need to copy it and you need to move on to the different machine. Ingestion is something, say you are moving data from one location to another, in order to process it. So might be like the customer is having data onto their on premises. So what you need to do in order to process that particular data, you need to move that particular data from their environment to our environment. We will store that particular data over there, and onto the stored data we will be processing it. And once the processing is done, then we will be able to get the outcome in terms of report, charts, and dashboard. So like the data engineering flow, like where these data engineering is working, so up to over here, the data ingestion, data storage, and data processing, we are having data engineering. Okay. And once the data is processed, okay, then it will be given to data science team, data scientist, data analyst, or data scientist for the analysis perspective. Okay. So this particular course module will give you the insight about these particular aspects and these particular topics, or you can say domains, subdomains: data ingestion, data storage, and data processing. We will be going in detail like how the data will be ingested from one location to your environment. What are the different formats over there? What are the different tools that you are going to use? So data ingestion is done. Then what type of storage you are going to use? Okay. And in which format you are going to store, that will be covered inside the you can say data storage. It might be in other words like data lake, data warehouse, okay, database, so that can be of three type. Then once the data is there inside the storage, then you are going to process, and based upon the logic that you the based upon certain you can say stuff, or based upon the certain input that you got from the domain expert, and you will be able to process. Once the data is there, process data is there, it will be given to the different teams in order to you can say visualize in terms of dashboard, report and charts. And further, like, it will be analyzed by data analyst and data scientist, say onto this particular data. That particular team is deploying machine learning algorithms in order to get the insight, you can say, like, the trend for what will be the trend for next 5 days for stock market, what will be the weather for next 10 days. Okay, so such types of you can say predictions they will be able to map onto the data that we have given to that team, so that is inside the data analyst and data scientist world, although like we will be covering certain basics about these particular algorithms, okay, but our main focus will be towards the data engineering, not the data science. Okay, so that will be our journey from data ingestion to data processing. And only the limited work is there. If you are having the information about the process data, then deploying machine learning algorithm will not be a big deal, huh? Okay, so that is the stuff. Like, this particular module will focus onto the data engineering topics. Okay, we will be covering different topics. Now, you might be interested, like, what is the course module, huh? So, with respect to the course module, we will having certain topics. So over here, like, we will be covering introduction to big data, HDFS concept, along with the Linux command, then distributed processing framework with PySpark, huh? So once you are able to get the information about big data, we have already discussed HDFS, like how the data is stored inside the HDFS and how it will be processed with the help of Hadoop. So it will be there inside the first first module. Then we will be learning Spark. Then what I have mentioned, this particular course module is cloud based, so we will be learning Azure and AWS cloud. And from the Azure side, we will focus into the Azure Databricks, Azure Data Factory. Then these particular things are based upon the batch processing. Then Spark streaming will be covered. For Spark streaming, we need to have one event processing mechanism. So Apache Kafka will be Apache Kafka will be covered over there. Then more services on cloud. Okay, so over here, like, we will be having focus into the remaining services what are there inside the Azure and AWS. Interview readiness, we will be going through certain mock interviews. And additional modules, like, we will be giving you certain insight about Python, SQL and big data projects. So these things will be in our additional modules. The course duration will be almost for 4 months, and the classes will be there onto the weekends, uh, Saturday and Sunday, 3 hours each. Okay, like 3 hours on Saturday, 3 hours on Sunday. Okay, it might be possible, like we can conclude the session plus minus 15 minutes, 15 to 30 minutes. Like, some time we can go up to say 3 hours 30 minutes. And someday, if like the topic is heavy, you are not able to digest more and more content, then it will be, you can say, concluded into the 2 hours 30 minutes. So that will be the course module that we are going to cover. And what about the key takeaways, like what we have discussed? like data is increasing day by day, and data is big data analytics is there in each and every domain. We have gone through with the different domains, and we have seen different domains examples. Okay. And big data active use cases there into the different domains. Then we have seen like Hadoop distributed framework, how the data is processed inside the Hadoop. Then we have seen certain core components of Hadoop like SDFS, Hadoop distributed file system, Yarn. I have not covered Yarn, but I have covered resource manager. The resource manager is nothing but Yarn inside the Hadoop. So Yarn is there for resource manager, and MapReduce for the processing that we have covered. Hadoop ecosystem includes multiple component that support each stage of big data processing. So different component, what we have seen, like we are having different stages. Say Flume and Scoop for ingestion, okay, SDFS and SDFS for storage, and HBase for querying onto that particular data, Spark and MapReduce for processing, Pig and Hive Impala for the analysis perspective onto the data, Hue and Cloudera Search in order to have the data exploration that is providing the GUI view. Uzi is the workflow, you can say, system, and it is utilized to schedule the jobs inside the Hadoop ecosystem. So these are particular things we have seen in our today's session. Now, the very important stuff, like why, like you need to go with the session from our side now. So, guys, we are the working professional. We are working into the same, you can say, domain, and we are going to start from the scratch, and we will move toward the advanced level. Okay, our main focus will be on to the practical side. Theory and practical will go hand, so you can say, step by step. First of all, like we will be covering the things with theory, and then practically it will be explained. Then you will be having the repeated online sessions. Say if you are not able to, you can say, cover the topics in one session, then you will be having, you are free to, you can say, register for the another batch, and over there you can clear your concept. We will be sharing you the recordings and all. With the help of that, you will be able to clear your doubts. Then effective course module or materials. So the course material which I have shown, that is you can say more in detail, and it is best in market. It is covering all the required things, tools and technology that is demanded inside the market, or demanded in the organization. Because like we are working on to these particular technology, so we are having the idea. Okay, so because of that particular reason, the course module is designed in such a way. Then domain examples. So we will be going through with certain domain examples. Say someone who is working inside the telecom. So examples will be taken from telecom. If someone is from the finance background, we will try to give the example from the finance background. And at the last, like job assistance and interview preparation, what I told, like we will be going through mock interviews and all. Okay, we will be assisting you in order to prepare your resume, how to prepare your resume, and how to mention technologies over there, how to manage your experience. It might be like some of you is having more than 10 year of experience, some of you is having 5 years of experience, so how to manage that particular experience. So those particular things will be covered, and that's why like you can, you need to go from our side. So that's it from my side. If you are having any doubt, you can discuss. Now you can ask anything, whatever is there in your mind, with respect to session, with respect to course module, with respect to the future, anything, guys.
Uh, Hi, sir.
Hi.
I have one query.
Do we
Mhm.
need any certifications for this course after like completing this course about the particular technology?
No, no, no.
Or
Actually, like certification, if you want to go with certification, you can go because like we will be covering each and everything in detail. So you can go with certification, but in organization during the interview, it is not asked. Okay, as per my personal experience, like
Mhm.
organizations are not asking, say, someone who is cloud certified, that particular person will be able to attend the interview. No, things are not like that. Huh?
Okay.
Hello, sir.
Yes.
Hello, sir. My name is
Uh,
Kishan, and
yes,
and
Kishan.
I have an query. Sir, is
Mhm.
there any eligibility for this course, like a degree? Because I am become a student.
No, 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 no. There is no any, you can say, eligibility. But the main thing, are you working or are you fresher?
Yes, sir. I am working.
You are
I am an
working, huh?
accountant. Yes,
Yes, yes, that is fine. Huh? So, what I can suggest you first try to think in that way, like how you will be able to utilize these particular tools and technology. Like, say, because once we will be having project, huh? What I will ask, like the data. Say, if you are working into the finance, then I will ask, say prepare project onto your data. Someone who is working onto the telecom,
sir. Is there any issue? Because sir, can you hear me? Is there an issue with your audio?